Hi, this is Mr. Cardoso again, and in this video we are going to look at yet another example of solving linear systems using the elimination method. And in this method we are going to, in the elimination method, we've already done a simple example. In this video we're going to do a slightly harder one in the case when the coefficients are not the same but can be made the same. So let's take a look at an example. Let's say we have, for example, y equals 7x minus 9, and the second equation is going to be 2y equals 9x plus 1. Okay, so now, if we remember from the elimination method, the idea is that we are going to find the variable that has the same coefficients. So let's look at the x. Let's look at the x term here. Okay, 1 is 7. The coefficient of this one is 7. The coefficient of this one is 9. Obviously, they're not the same. So let's take a look at the y and see if we have better luck. Here, the coefficient of this y is 1. And the coefficient of this one is 2. And as we can see, they're not the same either. So we can either abandon the elimination method or and go to the substitution method, or we can say, well, is it too hard to make these coefficients the same? So one thing that you can do is take an equation and multiply it, or divide it for that matter, by any number. As long as you multiply all of the terms in that equation by the same number, you haven't changed the equation. So that's allowed. So what we can do is I can see, can I multiply, for example, the 7 by something to make it a 9? In this case, you can't multiply 7 by anything, because 7 times 2 will give you 14. It's not going to give you 9. So if I wanted to make the x terms the same, that means I would have to multiply this equation by something and this equation by something. I'd probably have to multiply every term in this equation by 9 and multiply every term in this equation by 7, which would give me the lowest common multiple. That's a lot of work. So let's look at the y's. Can I multiply this 1y by something to get 2y? Well, if you said I can multiply this by 2 to get 2, then you'd be right. So 1 times 2 gives me 2. So if I multiply this by 2, that means I have to multiply the entire equation by 2. So I'm going to write that down below. So if I multiply this entire equation by 2, I'm going to get 2y equals 14x minus 18. Okay, so you have to multiply every single term by 2. The second equation, I don't have to multiply it by anything because now I already have 2y, and this is already 2y. So I've achieved my goal. Now that the coefficients on the y are actually the same, I can go ahead with my elimination method just as before. Now in this case, I need to subtract again because they're both positive. So 2y minus 2y will give me 0y. So I'm going to subtract the equations. Now if this happened to be a negative 2y, then I could add the equations because positive 2y plus negative 2y would give me 0. So you add or subtract depending on the signs. If the signs are the same, you want to subtract the equations to get rid of it. If the signs are opposites, meaning a positive here and a negative here, or vice versa, that means you want to add the two equations to eliminate. So in this case, both the signs are positive, the signs are the same, so that's why I'll subtract. Even if both the signs were negative, I would subtract as well to get rid. Okay, so 2y minus 2y gives me 0y, or just 0. So I've eliminated the y. Now we have 14x minus 9x gives me 5x. And then we have negative 18 minus 1, which gives me negative 19. Okay, minus 18 minus 1. So that's tricky there. Make sure you're subtracting all the way across. So now I take the 5x to the other side. I get negative 5x equals negative 19. Oh boy, this means fraction is going to be involved. So I divide here by negative 5, divide by negative 5, and then I get x equals positive 19 over 5. Okay, I can't reduce that fraction. The negative signs actually cancel out with each other, and that's my x. So part of my solution now is 19 over 5. Okay, now just like the substitution method, at this point you take your solution for x and you sub it into either equation 1 or equation 2. It doesn't matter, whichever one you think will be easier. So sub in x equals, oh boy, not working anymore, 19 over 5 into, now let's figure out which one would be easier to sub in. You can sub into the original, so ignore all the green and red, just look at the blue writing. Let's sub into the original equations. Which one do you think would be easier? I would think equation number 1 might be easier because y is already on its own. So it probably avoids one more step. In this case, you'd probably have to divide by 2 at the end. So let's sub into equation 1, and that would be a little bit easier. Okay, so y equals 7 times 19 over 5 minus 9. Okay, so then 7 times 19 is, use my calculator there, 133 over 5 minus 9. And again, I'm going to do this on my calculator. I can do 133 over 5, use the calculator button, minus 9, and I get 88 over 5, which cannot be reduced. And so I have my other part of the solution, y equals 88 over 5, and that is all. So in this, we use the elimination method. It turned out that neither coefficients were the same. So the x coefficients, 7 and 9, were not the same. The y coefficients, 1 and 2, were not the same. But we figured that with the y coefficients, we could multiply by 2 in order to make them the same. So we multiplied the whole equation by 2, and that made our y coefficients the same. And then we continued with our elimination method as normal. So even when the coefficients are not the same, if they can be made the same easily, then you can still use the elimination method. If they were both hard, in the case of the 7 and the 9, you can see that this is difficult to make the same because you have to multiply this equation by 9 and this equation by 7 to make those the same. If the y coefficients were similar in that they were difficult to be made the same, then that's when you would say, okay, let's use the substitution method. You could still do the elimination method, but it would be quite a bit more difficult. So in that case, where both of the coefficients were difficult, like here, and these ones were difficult too, then that's when I would give up on the elimination method and use the substitution method.